So today's lesson is actually kind of fun. I like this stuff. So there's a bunch of stuff up here. And pretty much what this lesson is it's a bunch of multiple choice questions, sort of. Okay? So you can read through this stuff as you want to. What I'm going to focus on is that we have 1, 2, 3, 4 XY tables. Do you see those? Each one is either an exponential relationship, a linear relationship, or a quadratic relationship. Okay? So it's pretty much multiple choice. Each one is one of those. Now I'm going to be referring back to your homework assignment. This is tonight's homework. And you have a bunch of XY tables again. And the first thing you have to identify, is it exponential, linear, quadratic, or none of those? Okay? There might still be some kind of a pattern, but it doesn't fit what it needs to fit to be exponential, linear, or quadratic. For two of them, if it is linear or exponential, I'm going to require an equation. If it is not linear or exponential, you will just write NA on your y equals line. Okay? By the way, one random thing on this, if you notice, all of the XY charts are filled out except one of them. There is a missing number in one of them. Do you see which one?
Yeah. Yes.
Which one?
Number 5.
Number 5. So the intention is that you can figure out what the pattern of number is to fill in that value. Okay? It's only on that one problem, but that's why it is intentionally left blank. That wasn't an accident. So, let me explain this stuff right here. And I'm going to explain that by starting off looking at these guys. The first thing I'm going to do to try and figure out if it's exponential, linear, or quadratic is I'm going to do what's called the first order finite differences. Huh? Finite differences. And this one talks about the second order, but I'm going to do the first order finite differences. Here's finite differences. You ready? Notice the x values. There's no change in them. It's 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. Right? Finite differences we find from our y values. So I'm going to look at 1 and 4 and see what did I have to add or subtract. We're not going to talk multiply or divide. Add or subtract to get to the next term. So to get from 1 to 4, I had to add 3. To get from 4 to 16, I had to do what? Add 12. To get from 16 to 64, 48. And then to get from 64 to 256, 192. Now, these numbers may have a pattern to them, but I'm not really concerned about that right now. Okay? That's my first order finite differences. Pretty easy, right? Let's do the rest of them. See if we notice anything interesting. To get from 1 to 7, what do you do? To get from 7 to 13. To get from 13 to 19. To get from 19 to 25. Huh. Notice anything interesting there? Hopefully you notice something. This one has a easier pattern to recognize than this one, right? We would say this one has a constant value for its first order finite differences. Let's see if either of the other ones have that constant value for its first order. To get from 1 to 9, to get from 9 to 33, you add 24. To get from 33 to 73, and to get from 73 to 129.
Ladies and gentlemen, that is a false alarm. That is a false alarm. Thank you.
Yeah, a false alarm.
There was I could hear a fire alarm going off out there.
Oh.
Sorry. Okay. Questions about this? Did I do that right? Check my math there. Okay. How about over here? To get from 4 to 12. Add 8. To get from 12 to 36. 24. To get from 36 to 108. 72. And to get from 108 to 324, 216. Okay? Now, one of these things is not like the other. Yes, you can sing that in your head if you would like to. But which one is different?
The one that's plus 6, plus 6, plus 6.
The one that's plus 6, plus 6, plus 6.
Plus 6.
If you have what we call the first order finite differences all the same, that automatically makes it linear. When your first order is constant, you have a first degree equation, which is a linear equation. So we've got 1 down out of 3. Okay? Now, what were the two things that I said you needed to write an equation for? Linear and exponential. So, if it is linear, I have to write an equation in y equals mx plus b form. All right? So I need to know what m is and what b is. So this 6 that we just found, guess what? That's m. What is b? Any guesses? On a graph, what's b?
Y.
Your y-intercept, right? Well, your y-intercept happens when x is 0. So guess what my b value is? 1. So my equation would be y equals 6x plus 1. Easy peasy? Okay. Now we're going to do what's called your second order finite differences. This was the first order. Second order means let's go one more step out. So how do you get from 3 to 12?
Multiply by 4.
Not multiplying, just adding and subtracting. Add 8. Add, yeah. Your 9s don't look like that? Just kidding. Did I do 36 right? 48 minus 12. Whew, did that one right. Okay. 192 minus 48 is 144. That's called my second order finite differences. Okay, let's do these ones. We're already done with this guy. We know it's linear. What have I got here? Plus 16 plus 16 plus 16.
Oh, so it's 16.
Huh. What about here? Plus 16 plus not 16. 48. And plus 216 minus 72 is 144. Now, of these three, one of these three things is not like the other.
This one, the bottom left.
Bottom left. Why? Because we now have a constant here. We didn't have it on the first level, or the first order, which means it's not linear. But if I get it on the second level, guess what? It's quadratic. Instead of a first degree equation, I now have a second degree equation. Now, remembering back to our polynomial stuff, do you remember that? The degree stuff?
Mm-hmm.
First degree, second degree. How do you think I would know if it was a third degree?
It was 3.
If the third order was constant. Fourth degree, the fourth order would be constant, and so on and so forth. Kind of trippy, huh? Okay. So I have linear, I have quadratic. Now I'm going to pause for a minute before I go over these two. Okay? I'm going to go up to, this is desmos.com. You guys are familiar with that?
Yeah.
Okay. This is the graph that will pop up, or this is the calculator, I should say, that will pop up when you take your SBAC test, the test that all the juniors take at the end of the year on the computer. Remember, it replaced the bubble tests, the CSTs. This is the when you're on that test and you click on the calculator, this is the calculator that pops up. Okay? So if I need to know what 2 times 2 is, I can type 2 times 2, and do you see it give me the answer? Right there. So I can use it for basic operations. If I don't know what to type in, I can click this keyboard and it will help me give me some suggestions of symbols that I can use. But what I want to do is I want to actually graph that linear equation. Okay? So going back to this guy, I'm going to take this chart and I'm going to graph those points, and then I'm going to see how my equation that I came up with matches up with it. So I'm going to type in the points. What's the first point? 0, 1. And then the next one is 1, 7. And then 2, 13. And 3, 19. And 4, 25. By the way, Desmos is an app you can put on your phone also. Free graphing calculator. We always like free. So I'm going to zoom in a little bit. Do you see all my points? Now we said it was linear. What is the linear equation we came up with? Y equals 6x plus 1. Does that line go exactly through all of those points?
It does.
Yes. So I just made an equation that matches up with the points on that table. Kind of crazy?
Very crazy.
Now, the quadratic one that we just did, we didn't have an equation for it. And that one I think is actually a little harder to see, but let me see. 0, 1, 1, 9, 2, 33, 3, 73, and 4, 129. That one is a lot harder to see. I can tell that it's not linear because the points aren't evenly spaced. This one has a much bigger space than that one does, right? It's a lot further to get to it. It's kind of hard to tell that it's quadratic just from looking at the graph. And since we're not going to be writing an equation of it, I wouldn't worry so much about the quadratics. But the linear ones where we have an equation, it's kind of nice to be able to check that. Okay? We will check some others though, because we still have two equations that we have not classified yet. What is my other option? Exponential. Now, exponential is going to lead us away from these finite differences, because finite differences only help us with polynomials. First degree, second degree, third degree, fourth degree, and so on. Exponentials are slightly different, and this notation might be a little confusing for you. So let me show you what this means. Again, I'm going to take my y values. I'm going to start with the second y value and make it a fraction over the first y value. Okay? Then I'm going to take the next one and make a fraction, 16 over 4. What would my next fraction be? 64 over 16. And then finally 256 over 64. So I'm taking the second over the first, the third over the second, the fourth over the third, the fifth over the fourth. Does it matter that I'm working backwards instead of forwards? Like, couldn't I just do 1 over 4, 4 over 16, 16 over... That won't help me when I go to writing an equation if it is exponential. Now, if this is exponential, each one of these fractions is going to reduce to the same number. So what is 4 over 1 reduced to? What is 16 over 4 reduced to? What is 64 over 16 reduced to? And I'm guessing, it's not clear on the top of my head necessarily, but 256 divided by 64, oh, what do you know? It's 4. So instead of having my constant in the first order or second order, I now have it with these little fraction things that I set up. There's my constant number. That means if it didn't work here or here, but these fractions work out, that we have something that is exponential. Okay? Now, exponential was the other one that on your homework I said you need to write an equation, right? Mm-hmm. Linear was y equals mx plus b. Yeah. Exponential is y equals ab to the x. So let me write that up here. Y equals ab to the x. And usually you're going to be putting parentheses around your b just to make life easier. Now, same way I found my b value there, I'm going to use that point where x is 0, but it doesn't give me my b value here. It gives me my a value here. My b value comes from here. So, b equals 4. So if I know A and I know B, can I plug it into that equation pretty easily? Y equals A times B to the x power. Now, do I really need that A value if it's a 1? No, not really, but it's not going to hurt anything to be there. Okay? So now I want to go back to my calculator and I want to see how these points match up with that equation I just came up with. Okay? So I'm going to go back to Desmos. And let's see, the first point is 0, 1, and then 1, 4, 2, 16, 3, 64, and 4, 256. So do you see my orange point is down here, the purple point is right here, black point is right there, there's the red point, and the blue point is way up here at 256. You see it? So now let's type in that equation that we came up with and see if the graph matches. What was the equation I came up with? Y equals what? 1 times 4 to the, now when I don't know how to do the to the, I can either use the caret button. You know what the caret button is?
Yeah, look like a little.
It looks like a little like roof line, like a little arrow pointing up kind of. It's above the 6 on your keyboard. Or you can click this right here where it says A to the B. If I do the A to the second, what does it do? Oh, it makes it to the second. I don't want it squared. I'm in backspace. I need it to the x power. And what do you know? Does it match through all of those points? What about the 256 way up here? Does it still go through that? It goes right through the middle of them. So if my equation does not go through those points, then I made a mistake somewhere. Okay? All right, let's try the last one. So, linear, exponential, quadratic. Let's do this last guy. It's not linear. It's not quadratic. Let's see if it's exponential. What's my first fraction? 12 over 4. That reduces to 3. What's my next fraction? What does that reduce to? Looking promising. 108 over, what does that reduce to? And 324 over 108, what does that reduce to? Look at that. If they didn't all reduce to the same thing, then what would it be? It wouldn't be nothing. I want to clarify. It's not necessarily nothing. It could be related, maybe it's a cubic relationship. Maybe it's a 4th degree relationship. It's just not one of the 3 relationships that we're concerned with. What are we concerned with? Linear, quadratic, exponential. So that doesn't mean it doesn't have a relationship. It just means it's not one of the 3 relationships we are looking at. Okay? Just like if you said, I'm a student, and I said, oh, are you a freshman? No. A sophomore? No. A senior? No. That doesn't mean you're not a student. It just means you're not one of the 3 groups that I asked about. Make sense? Okay. So, from here, what is my A value? 4. Forgot to write that it's exponential. What's my B value?
3.
From here, my B value is 3. So what's my equation? Y equals 4 parentheses 3 to the x. So let's go to our calculator. I'm going to go to the Desmos calculator, plug in those points, and check it on that equation. Do you have to do this? No. Do you want to know you're doing it right?
Yeah.
That's up to you. I like to know I'm doing things right. All right, 0, 4, 1, 12, 2, 36, 3, 108, and 4, 324. Now, that's not very helpful for you right now because I'm so far up there. There's my 3108. In fact, if I zoom out a lot, I have to zoom out a lot to see that last point up there because that one's at 324. So there's my points. I'm going to zoom in a little bit more though. And now I'm going to type in my equation and see what we've got. What's my equation? Y equals 4 times 3 to the x. It's going right through those, isn't it? Amazing. Oh, that's as high as I need to go, right? There's my 300. Okay. So it's just a way for me to check to make sure that, yes, I did get the right equation that goes through those points. Okay. So what did we just do? We took 4 relationships. You can't see what I'm pointing at. We took 4 relationships, identified whether they were linear, quadratic, or exponential. And for the linear and quadratic ones, we not only stated what kind of relationship that was, by coming up with an equation, that's actually a definition of the relationship of those numbers. Okay? We found the equation of the line or the exponential curve that goes through those exact points. Okay? Yes, question.
If it wasn't anything, what would you say?
If it wasn't anything, like on your homework, you would say none of these. Okay? So, only if it is exponential or linear are you going to have something to fill in on this y equals line. If it is quadratic or neither, you're just going to write NA. Quadratic, we could write an equation for. Same thing with neither. We could usually write an equation for those. It's just much more involved to get to that equation, and we're not going to take time to do that. Okay? So we're just going to say, not applicable. We're not covering that part today. Okay? All right. Happy studying.